Hello, everyone. This is the meeting for the QUIC working group. If this is not where you expect to be, you can stay if you like. We're nice here. But otherwise, we're going to get started. As a reminder, there is a clipboard that is probably circulating, but that clipboard really just has a QR code for bringing you to the on-site tool, which is how we track attendance. And it would be nice if you did that so we can pad our numbers and make sure that everyone knows that QUIC is important. And yeah. So moving right along, this is a reminder that this is an IETF meeting and thus is covered by the note well. If you have not noted the note well, please do so. Also, all of your conduct is covered by the IETF Code of Conduct, which we take very seriously here. And some more tips in addition to the QR code thing I already mentioned. If you are joining the queue, you will need to use the on-site tool. It can be a little bit funny, but just keep with it, reload it if it's not working, but that is how you join the queue. The chairs will do our best to dequeue people from the queue as needed. For remote participants, please do the normal thing of muting your audio and video when you're not speaking. Generally, people have a pretty good job of that. Also, we can just mute people that are not doing that anyway. And of course, using a headset is strongly recommended. And we will also be reading any questions from the chat that is either in the the MeetEcho chat tool or on Zulip. And we already have a note taker, so thank you again for that. And this is our agenda for today. So we have brief chair updates, then we have a good number of working group items, and then we have some, if we get time, we will have a couple other topics that are not currently working group items, but may be of interest to the working group. So updates since last meeting, we have 2 new RFCs. So, and that is compatible version negotiation. Yeah, some people may have forgotten that we have compatible version negotiation, and we have a whole new version of QUIC. So thank you everyone for your contributions to that work. And that is it for our slides. So now, who's presenting for multipath actually? Okay.
Should we start? Okay. Hello, everyone. I'm Yanmei from Alibaba. Today, Quentin and I will introduce the topic of multipath extension for QUIC. Slides, please. Okay, today we'll introduce the difference between 04 to 05, and of course, we have a hackathon of interop tests where we will do the interop reports, and we will discuss the open issues and, of course, the next step of this draft. Okay, although we have merged lots of pull requests on the GitHub, but the most important change in this version is that we update the new transport parameter and the frame types. The first important thing is that we update the new transport parameter value. As we don't need to support narrow length connection ID anymore, we don't need the value of this transport parameter. So we just introduced the enable multipath as a narrow length transport parameter, and we update the version to 05. And by the way, the enable multipath transmitter must not be remembered and stored with any session tickets while use with narrow RTT, because all the multipath features should be used with one RTT packets. That's just how things works. Next slide, please. Okay, the second important thing is that we update the frame types and error code. We replace the frame type with random numbers, and you can see the new types here. And we have applied the IAM registration for these new frame types. We will get shorter ones before the last call for adoption. And by the way, we update the error codes for MP protocol violation, and we use the frame encoding error while receives multipath specific frames in packets except the one RTT packets. For example, if you receive an ACK-MP in the handshake packets, you should update frame encoding error. It's a more specific error. Next slide, please. And we update the CID usage in multipath as we have removed the virulence CID support in the current draft. We remove all the stale statement about this, and we suggest implementations should should have at least one available CIDs unless they don't care about rebinding. Next slide, please. And we add some guidance about the RTT computation and the ACK-MP scheduling. The point is that implementations can choose different ACK-MP scheduling strategies, such as they can send in ACK-MP frames on the path the packets was received, or they can send ACK-MP frames on the shortest path. But for both considerations, they need to compute smooth RTT and RTT variable per pass using the algorithm specified in quick recovery. And some congestion control functions may rely on the estimate of the mean RTT. And so we given one solution here that endpoints might remember the path over which the ACK-MP that produced the mean RTT was received. And once they find that path is abandoned or changed, they can restart the mean RTT computation. Next slide, please. And we add some editorial guidance in this draft. People can check the details through the diff. We claim that zero RTT packets should be acknowledged by ACK-MP friends, although you can just send ACK-MP friends in one RTT packets. And we clarify that path abandon and path status are ACK eliciting. Also, the eliciting counts are per path, not per connection. That's different from Quick version 1. And we clarify the effect on the transport machinery when people receive path abandon and after 3 PTO timeouts. And of course, about the nonce usage and other things, please feel free to check the details. Next slide, please. Okay, the last important thing is that we update the key update mechanism. In the last version, endpoints need to send packets on each path when key update happens. This is sometimes a waste and it's not very efficient. So in this version, as Martin has pointed out on the GitHub, that endpoints may wait for at least 3 times the largest PTO among all the passes before initiating a new key update after receiving an acknowledgement that confirms the previous key update. We all think that's an elegant solution, so we update this and merge this in this draft. And it's different from what Quick version 1 has claimed, that they just use 3 times the PTO, they only one active pass. Just feel free to check the diff. Next slide, please. Okay, and this is the interop report. Before Quentin introduce the report, I really would like to say that we already have 5 implementations which supports multipass. And I think we have 6 on the client side, as our Apple friends has claimed that they support multipass on the client side. So, and we have this nice hackathon interop report. So I think this is really a big step of this draft. And thank you for everyone.
Okay, so it's Quentin. We can keep the slide actually. Yeah, so actually it was during the hackathon, so we did some interoperability tests between the different implementations. Some were implementing version 4, others were implementing version 5, some were implementing both. And so basically what we did is just check if we can negotiate multipass, if we can create paths, and then if we can just split data across several paths. And so the bottom line actually of this implementation interop is that actually we managed to do multipass between all the implementation in some way. Of course, later we will need to do like performance interop as well, but this will be for later. So next slide. Yeah.
Quentin, can you just stand on the...
Oh, sorry. Yep. Sorry. So next slide, please. So now we would like to discuss some open issues that we have. So the list is here. So let's start with the first. Next slide. So we still had some discussion at the last IETF about what to do with the path status frame. So currently what we have is that we have one frame, and then that frame defines a value to define the status of the frame, and we have defined 2 values, the value 1 for standby, I think, and value 2 for available. And the question was, do we want to keep this frame with a value, or do we want to instead split the frame into several frames, such as a path available and path standby, knowing that we need to keep a sequence number between these different frames? So in the case of the split frame, we need to have one sequence number that is shared between the different frames, because the status of a frame may change. Or if we prefer to keep the path status frame as its current form, we need to define what to do if you have some value which is unknown or unexpected. So if you have any point on this.
Yeah, Kazuho.
Kazuho, I think this is a backshade regarding how you send the state, either in a frame type or either as a distinct property of a field. And I don't think we have had new information since the previous IETF meeting. And if that understanding is correct, I'd prefer following the previous consensus of using different frames.
Yeah, I agree. I think it doesn't matter that much. I think I prefer the first solution here. And as Kasu pointed out in GitHub, like this is not the first time we're actually using this between frames. So I think that's fine.
Okay. Christian?
And the main advantage of using multiple frames is that we do not have to create a specific registry of path status for the IANA. So it's slightly better. The multiple frame is slightly better because it means less administrative burden for the IANA. The only question is that you do have to maintain this sequence number across all these frames so that they get right. That's the only constraint.
Alessandro Ghedini, Cloudflare. I agree. The splitting the frame into 2 is probably better, and it's also going to be easier to add additional statuses that might require additional information, so that we won't need to actually change the path status frame itself, but also just add a new frame.
Okay, thanks for the input. So Next slide. So yeah, this is also a small issue. So currently about the error code that we only have one error code, which is very specific to multipath, which is multipath protocol violation. And the current rationale behind only having one value is that you can then in the connection close frame have additional value to indicate precisely what you have as an error. So do we want to have further error code, or do we just keep the current rationale of only having one? And then having connection close that can just have further error code.
Alessandro Ghedini, Cloudflare. I don't think so the error code might be useful for like interop, I guess, but as you said, like you can just use the reason field. I don't think we need more, but I don't know if anyone else has opinions.
Yeah, I'm trying to remember stuff. Is this? I think we're only using this error code in one place at the moment, which is like if you try to negotiate and you don't have a connection ID, then you're putting this error code in, right? And then like I think there's also error conditions where like something is wrong with the frames, but that's where we use more generic frame type error codes, I believe. Yeah, so this is only used for the handshake. We don't have another use. And the point of this issue was to like more holistically look at like where we use which error codes and if this is actually the right approach. I think the only question here is really we could rename this error code because we only use it in one place. But other than that, I think we are at the right point now. But like it kind of, because we just changed it in the last version, so we don't really like had like, and we changed it at a different point of time, so we didn't think about the whole concept. So we should make sure we do it right.
Actually, we did think about the whole concept, and there is a trade-off there. You can, if you have multiple error codes, then it will be present whether you're in debug mode or not. Whereas if you rely on the reason code, you can have a programming switch in your implementation that only set up the reason if you are not in debug mode, if you are in debug mode. And it has implication on the overall security issue, because effectively by disclosing more information about the error code, you disclose information about the internal state of your application, and that can be used to various attacks. And so it's generally preferred to say less and rely on the reason code and put the reason code behind some kind of debug switch so that you can be very precise about what's happening in debug, but not in production.
Christian, stay here for a second. So do you even think we don't need this error code and we should use a more generic error code for the handshake problem?
I mean, having one is fine for but that's we certainly don't need to have 24.
Well, actually, in the next steps that you are going to present, there is the security consideration that we need to write. So maybe this is related.
So just one thing about this. We had a discussion over the weekend about error codes and what it is that when it is that you can send them and that sort of thing. I think it's probably worth airing here a little bit about the conclusions that we'd reached privately. There was a concern that someone would send this particular error code in the case that one side attempted to do some multipath thing during the handshake, but it was you hadn't sent the enabled multipath transport parameter. And our conclusion was that no matter whether the other peer has sent you any indication that they support a particular feature or what have you, you can still send error codes related to that feature, which has implications for the use of error codes more generally. But I think that that's probably something worth thinking about here as well. It just simplifies things, I think, in this case, more than anything else.
All right, so next slide. So this one is about non-validated paths and ACMP. So what we do currently in multipath is that when you want to create a new path, you need to do a path validation on it. So you send a path challenge, and then the server needs to reply with a path response. And the goal is we want to acknowledge that packet. So can we just actually put the ACMP in the path response packet? So currently what we can do, and that works actually, is we can just send the ACMP frame on a different validated path, and this is because actually the ACMP frame is a non-probing frame. So if we want to make it work and put ACMP in the path response packet, actually we need to make the ACMP frame a probing frame. So do we want to make this, or is it just fine to keep it non-probing and send the ACMP on another path?
Kazuhoku, I prefer simply removing the concept of probing and non-probing frames in multipath. If I recall correctly, the reason we have the distinction of probing and non-probing frames is that non-probing frames have to be tracked by loss recovery, and because with quick V1 it is hard, if not impossible, to handle loss recovery of multiple paths concurrently. That's the reason we have used the transmission of probing frames as a signal of migration. But with multipath QUIC, we have loss recovery on every path. So I think we can simply say that any frames, regardless of it being probing or non-probing, can be sent at any moment and call it a day.
Okay.
Yunfei from Alibaba. Actually, thinking about this problem, we need to think about why we need multipath in the first place. I think one of the most important reasons is to offer like redundancy and communication robustness, right? So in that sense, if you send ACKMP on another validated path, that's a coupling between two different paths or more different paths. I think it's not good for redundancy purpose. So I really think that we should make ACKMP a probing one and allow it to send directly from the new path.
Okay. Question?
Completely agree with Kazuho on this one. If we have documented support for multipath, then we can just as well abandon the concept of probing packets, because we have other ways to validate a path. I mean, the way to validate a path for explicitly by the client is to send a path status saying that the path is available. Now, if the client doesn't do that, the server has to guess. But if the client wants a specific handling, it can send a path status and set it to available or standby, and there is no ambiguity. The business of trying to infer from some type of path that the client might wish to do something is very error prone. I must say, for example, that in my implementation, I always send an ACMP with the change response. Because, I mean, you have the bytes, you have the packet, you can just send it. And I always process all the packets received on any path, because if they have been sent by the other end and the checksum matches, they are good packets, so you can just always use them. So I think it's Kazuo is completely right there.
Yeah, Eric Kinnear, Apple. One thing to think about if we're doing this is kind of what Christian was saying. At some level, validation is proving that you can respond and arguably echo some data, right? So either we say this is fine to make a probing frame and we figure out how that plays into some of the amplification limits, right? Because if you start sending a bunch of ACKs and chewing up that data, you may not be able to respond to a challenge. Or we say, no, you have to keep those very strictly separate, and the only way to validate is one thing. But like, the point of validation isn't that you responded with a particular frame. The point of validation is that you exist and you have the keys and you can respond and you can see the data that comes in.
All right. Then maybe the next slide.
Oh shit.
Yeah, so it's also a tricky issue, this one. So we might be in a situation because we use the connection ID as path identifier. And if we are in the case where you experience NAT rebinding, for instance, or a change in for tuple at the same time that the client changes connection ID, actually you will observe a new path at the server side with a new connection ID, but at the client side, actually it refers to the same for tuple. And so how should we actually address this case? Because it will appear as a new for tuple without having some proper path validation, but as we discussed previously, just to check. So to create a new path. And so there are different options to actually cover this case. So either we let the server figure out to which for tuple it corresponds, or we can tweak either the retire connection ID, the path abandon, or define a new frame, which is very specific to that case. So maybe it would be nice to hear opinions.
Just wanted to point out that this is would be solved by introducing explicit path IDs. I
Which
saw
is
you have a slide, and we'll discuss this later. So maybe we can.
Yeah. So actually, we can
discuss
actually move to the next issue, which is actually a good one. So this is actually first a background slide to explain what we want to do. So currently, this issue, we have that what connection ID correspond to one packet number space, so it has its own quick path. So it means that if you rotate the connection ID, even if you are using the same for tuple, it corresponds to a new quick path, and so with a new packet number space. Because you rely on connection ID, this means that you can have at most the maximum number of connection ID that you might have on your path, the number of paths that you have. So if you can have up to 8 connection ID on a connection, you can have up to 8 paths on your connection. We have that all these paths are sharing the same key, and so we have the key update stuff that where you need to synchronize your paths, and so that's what we actually fix in the 0.5 version. It also means that you may have gaps in the sequence number of the connection IDs because you might still using connection ID 0, but then 1 to 3 is retired, and then you are at connection ID 1083, so that's possible. Because we do that as well, we override the connection ID feature of RF 9000, so we change it, and we use the abandoned path to request you to close a given for tuple. Next slide. So the idea of this issue is to say, okay, let's pre-assign the connection ID to some path identifier. And how can you do that? Actually, instead of using the new connection ID frame, you use an MP new connection ID frame stating that this connection ID belongs to that path identifier. And so you will have a set of connection ID that will share the same packet number space. And so it means that if you rotate the connection ID over a given for tuple, if you use a connection ID of the same path ID, actually you still use the same packet number space, and there is no ambiguity there. You can also explicitly state the number of paths that you want to be able to simultaneously use. So we can define a neutral parameter stating the number of maximum active paths that you can have, and then you specify the number of connection ID that you can have for each path identifier. And so this actually decouples the fact that you have 4 tuples, so the network paths, from the quick paths, which are actually corresponding to packet number spaces. And with that design, actually, we can also have, we can also define different keys, and we can have mechanisms just to have specific keys for each path identifier. We keep the sequencing of the connection ID sequence number per path. This would also mean that we keep the connection migration feature, but on a per path ID level. And we can also define then a frame to say, okay, we want to close a path. Okay, let's close the path ID, retire all the connection ID, and that's it. And so we do not need the path abandon stuff that we have currently. So that's a quite important design change. So maybe this would deserve a lot of discussion.
Kazuhoku, I think The downside of this proposal is that it is a very disruptive change. Specifically, it changes how paths are identified by the four tuples are managed.
Mike, please, Kazoo.
Sorry. In QUIC-V1 and multi-path draft, each path is a direct property of the connection state. But in the proposed approach, each path as identified by path IDs will be managing multiple paths identified by the four tuple. This is because net rebinding happens within the path ID space. If that happens, within the path ID space, endpoints have to keep the old four tuple while probing the new tuple. To paraphrase, we'll be departing from the one-layer approach that we have had in QUIC-V1, moving to a two-layered approach, and that's going to be a complexity to endpoints that already support path migration. The bright side of this approach is that this proposal is by far the simplest approach being proposed. So I think there's the bright side, but it's complex.
Yeah, so it's true that you need to be a little bit careful to think about the when thinking about net rebinding, because net rebinding will now appear as so as a server receiving a packet from a new four tuple can be the result of a net rebinding. So you need to probe that new path now. So it's difficult to because we don't have the right terms here. Like there's the one path identified by the path ID, but now if there's a net rebinding, there's this other four tuple that now needs to be probed. So we need to be very careful to distinguish those. We don't need to have a new congestion controller and loss recovery context, but we will need to run a probe on the new four tuple.
Yeah, exactly. So actually, you may have different four tuples on the same path identifier at some time, but given to that path identifier, you can only use one at a given time to send non-probate frames.
Yes, so this is basically in line with what RFC 9000 says, that you only have one congestion controller, and here we have only one congestion controller per path. The upside of this proposal is that it's immediately clear that a net rebinding happened, and that it's not an intentional migration event, because the server can see which path ID the packet belongs to, because it can just look it up by the connection ID.
Yunfei from Alibaba. I remember that we also had this discussion a very long time ago. I think at the time the conclusion was it's very difficult for you to pre-assign CIDs to different paths, because maybe in the first place, for example, if you have a lot of paths and if you have an application that keeps connection running for maybe 1 week, and you actually in the first place you don't know how many paths you are going to use, so the assignment becomes quite difficult. I think it's a challenge here. And the second thing is we are talking about net rebinding and net rebinding. But in our experience, that if you keep sending ping frames on the passive, and you can, I think net rebinding is not that frequent. I think, but here I really think that we should do more measurement to verify how frequent net rebinding can affect you. Yeah, I think that's the second point. And the third point is I'm also trying to understand why we do not want gaps in the CID sequence number. I think in operation, it doesn't affect me that much. What was is there a strong reason we don't want that?
Well, actually, the point is that it's not only specific to NAT migration and so NAT rebinding. It's also a way to limit and force the maximum number of paths that you may simultaneously use. So if you want to allocate some specific resources because you want to support up to, let's say, 2 or 3 different paths at the same time, you may have more network paths, but you only want to support up to this number of paths that can be simultaneously in use, because each path in use actually maintains some state. And so if you have a lot of network paths using a lot of different connection IDs, you need actually currently to keep state for each connection ID. So each packet number space and congestion control and so on for each connection ID.
We're effectively at time, but I'd like to drain the queue on this topic and then see if we can draw any kind of conclusion. Okay. So Christian, please go ahead.
I really don't like that proposed change because I think it mixes up many problems in a single thing. The first, I mean, whatever we do, I think we have to separate the decision about encryption keys and the decision about paths. We know that having multiple encryption contexts increases the memory of an idle connection a lot. And so I would be very reluctant to see that. The other thing is that limiting the number of paths goes into the problem of having temporary paths doing NAT rebinding. I mean, if you say I have only 2 paths and one goes to NAT rebinding, suddenly you have 3 paths and you need the 3 of them. Otherwise, you cannot resolve the NAT rebinding. So there is a problem there. If we solve that problem, we can have a transport parameter that states the maximum number of paths that one node wants. And that we can do that regardless of how we do it. So we could separate it. And I also think that this business of managing loss, packet loss, and managing congestion control, I mean, my implementation has only one congestion control per pass, even if the connection ID changes. That's trivial to do. And the same thing is true for the loss recovery. You can absolutely do it too. It's a bit more complex than for the congestion control, but it's not an actual problem.
Miria, if you could keep it brief, please.
I try. So having a knowledge of a path is like a concept that you can also apply with the current setup we have. It's just like it's not baked into the protocol. It's not that you have to signal it, right? But like you can have this concept, and I think that's what Christian is doing by saying he keeps the congestion control. The only case where it fails in the current setup is the case that you described on the previous slide, which is when you get a NAT rebinding, so you have 5-tuple or 4-tuple changes, and you happen to have a new CIT at the same point of time, which can easily happen after an idle time, right? Where like you as a sender just decide, you know, I haven't sent so much for so long time, so I use a new CIT. So it actually can happen, but this is the only case. It will not happen very often. And this is also a case where actually congestion control is not a problem because you just had an idle time, right? So your congestion control should anyway be low and you should be careful. So I don't think congestion control is a problem. The problem we've been trying to solve on the previous side is just like on the other hand, you don't know that it's the same pass. So you believe it's 2 paths. And if you try to send on the old pass, which was not actually a pass, you just fail. So you don't want to send on the old pass anymore. You want to, like at some point you will fail. You will take nothing go through and I have to close the path, right? So the only problem we want to solve here is to close this path as quickly as possible. So you know you have to send on the new path. So this is for me the only open problem we have. And I think there are other solutions to it that are actually more lightweight than introducing this whole concept of a path into the protocol and actually put it on the wire format.
Yeah, I'm just going to join the crowd of people against this change. Having 2 layers of concept of path, where we have path and address tuple or something, I don't know exactly what it is particularly problematic. The idea that you might get a NAT rebinding within this and not treat this as though it were a completely new path, I find a little difficult to reason about. The other thing that I think sort of came up in this was if you allow NAT rebinding, you also allow the client to simply change the path on which it's operating completely in this context. So in Quick version 1, the client can just move to a completely different address, and that's fine. But it's a different path. And one of the great advantages of this particular revision to the protocol is that we are treating them discretely and one layer rather than having this 2-layer mechanism. So again, I'll join the others.
Okay, thanks. We're at time. We need to move on. I'm not seeing any real strong conclusion there. There's some pros, but there's cons too. I think maybe folks need to go back and maybe take some of the things that people want and come up with a slightly different approach.
Yeah, so in any case, we should continue discussing on the issue,
Yep.
which is on GitHub.
Yep. We're gonna have to move on.
Yeah, so in the next steps in the end, so
Great.
not very surprising. So thanks.
Thank you. Martin, could you come up? So we're moving on to the next agenda item of reliable stream resets.
Yeah, no, I'll try to keep this short. Next slide, please. So updates since Yokohama. Kazuha joined as a co-editor. Thank you for that. Can you upload the new version of the slides, please? The one I sent you. Okay, I'll keep talking through the slide while the chairs update the slide deck. In Yokohama, we realized that naming the frame reliable reset stream is a little bit confusing because when you implement the extension, it behaves more like a fin with an error than as a reset. So we settled for closed stream for this revision of the draft, and was also requested that we add a variant that doesn't have an error code. So now there's two variants of the closed stream frame. How are we doing with the slide deck?
Yeah, we're trying to change the slides to Martin's updated ones, since a chair that will not be named may have uploaded the wrong deck. The silence is intentional, Christian. Lorenzo, if you're listening, we do need a slide update. I can't. It doesn't let me. You can't. It doesn't do anything. No, when you. Yeah, for anyone that's curious, the reason that this is a problem is that.
Let's just go with the old version.
Yeah, you can. Yeah, try.
Yeah, meet echo. because people are starting to leave the room.
Hi, I'm Altana from Cisco Meraki. In the meantime, could you possibly describe what do you mean by reliability in the reliable reset stream?
Yeah, I had a slide for that, but okay, I'll do it without the slide. So in Quick version 1, if you reset a stream and you have like a bunch of stream frames that are still outstanding, you will not retransmit those stream frames if they are lost. Right? You will only if you send a normal FIN bit, you will make sure that delivery of the stream data is reliable. But as soon as you send a reset stream frame, you just say like, okay, if any of those packets are lost, then I won't retransmit it. And this extension to Quick is intended to declare a part of the stream at the beginning as reliable, and then reset the stream and say like, okay, everything up to the reliable size will be retransmitted, and everything after that, I will not retransmit. Yes, there we go. Nice. Yeah, this is the slide to what I just explained. Next slide, please. So now we have the closed stream frame, which contains a field with a reliable size, and an optional application error code field. So depending on the frame type, the application error is there or is not there. Next slide. It was pointed out by MT on the list that this might be problematic to have a variant that doesn't have an error code. And I basically copied this from the email that he sent. So we have the following 3 cases. We have like you send data and you want the peer to keep none of this data. You just send a reset stream frame. The second case is you want to have a part of it being delivered reliably, but discard the rest after the reliable size. Then you use the closed stream frame. And the third case is you want to keep all the data. Then you send a stream frame with a FIN bit. So depending on on the API that you on the stream API of your Quick stack, this might or might not be a little bit awkward if you receive a closed stream frame without an error code. So imagine the case where you've transmitted, let's say, 100 bytes, and they have been received. And now you receive a closed stream frame with a reliable size of 50. So if it does have an error code, well, that's totally fine. That's basically your reset stream code path that you already have. But now what do you do if there's no error code? Like, how do you signal this to the application? And as I said, like in some APIs, this might be complicated. In some other APIs, this might not be a problem. The general, so the editors of the draft kind of struggle with this a bit, because while we have a very clear use case for closed stream with an error code, we don't really have a concrete use case for closed stream without an error code. And it's always difficult to design something if you don't have a clear use case in mind. So unless we get feedback from the room that we really want to keep the closed stream without an error code, we would remove that for the next version of the draft. Next slide. Then there's 2 more things I would like to get feedback on. The first one is the frame type, and in the current version we are using a 1-byte frame type. There's only 64 of them, so we need to be a little bit careful about using them. The justification for using a 1-byte frame type here is that this frame is basically equivalent to a reset stream, or will be sent in a lot of cases where otherwise you would send a reset stream frame, which has a 1-byte code point. So it would be nice to have the same property and to save some bytes on the wire when you send this frame pretty frequently. But just wanted to check if there are any objections to that. The second one, next slide, please. So the name of the frame, should we keep closed stream? Should we if we remove the no error variant, should we go back to reliable reset stream? Should we do something else? Don't think we need to discuss this here, but if you have opinions on this, then maybe send them to the list, and we can rename it if that's the conclusion.
Yeah, I just wanted to point out that's a bike and a shed, not necessarily a bike shed. I'm sorry. Let's go back to the previous slide, please. Oh, it's only Tuesday, people. I have no objection to one. I would have been fine with two, but I think we have plenty, and we're not really using them up at any great rate at this point. So I'm good with one. This seems like it seems to me almost like the default position for this particular working group should be to look at the 1 byte space, unless we're starting to take a large chunk of the space, and that may be true of some of the multipath ones where we start to look at the 2 byte ones, but otherwise this is core functionality.
Mm-hmm. Victor?
I wanted to say still 1 byte is fine, especially in QUIC where we don't have as much problem with colliding numbers because you have to pre-negotiate all of the extended frame times regardless.
Yes, but they are also IANA registered.
That is
so
true,
we can't double book them.
Yeah, but
Would you like to respond, Martin, or will you wait for me? No. Okay. Taking off my chair hat, I think 1 byte's fine for this. I do agree, maybe putting the hat back on, that we should try and think a bit more about, like, the things in this group get priority for the lower spaces than others. Maybe not, I don't know, but it's a good idea to keep in mind, maybe in like a few years' time where we are getting close to the end of those things, and to be a little bit more discretionary about that. And we have the designated experts on that, but it's also a working group matter. So what I'm hearing from myself and others is 1 byte probably seems fine. The question I have though is, are we going to do that now, or are we going to keep using some kind of TBD code point until we're happy that the frame is good to go in case there's any interop issues, etc.?
The current draft uses 0x20.
So
yeah, it's fine.
We're busted anyway. Okay. Yeah.
I think it's perfectly fine to continue to use the low order code points because the transport parameter will differentiate between the different uses. The only concern there is if someone wants to implement multiple versions of this particular specification and also like concurrently use them. We end up in a bit of an interesting situation. But we can deal with that problem when the code points or when things change. So if semantics change, then we may have to pick a different code point, just so that we can deal with that particular problem. Particularly since people are actively relying on this right now and looking to start building it. Web Transport looks to use this. That was my other point, which is that in the Web Transport setting, there's the potential when people are using something like mock that this is going to be used a lot. And that sort of argues for the 1 byte code point as well.
I just to respond, I was going to make a similar point too, but I wasn't sure, so it's good to hear it from others. David?
David Skenazy, a Varant enthusiast, I guess. So what are you planning on doing for the transport parameter in terms of how many bytes that is?
It's currently a random value, as it should be.
Yep.
I would like to get a small value there.
So
since you only send it once, I don't really care if it's 1 or 2 bytes.
So that makes perfect sense. That's what we did for version negotiation, where we waited until quite late in the process. I think from memory, we decided end of working group last call was that point. when we moved to lower values. And so you'll want to do that for the transport parameter no matter what. I would say do that for the error code at that same time, because you're going to have to make a normative breaking change no matter what with the transport parameter. So that kind of solves all of your what if we change it problems, and then you can resolve it then.
Yeah, so the plans until Prague is shipped a 02 to incorporate the feedback that we got here. I don't know if after that maybe we are ready for working group last call. There's no other outstanding issues. Would be nice to get some more interop. We currently have interop between Quick Go and Quickly, but it would be nice to have a third implementation at least. Well, we don't.
So yeah, just on the interrupt note, I mean, Martin Thompson seemed to imply that there's some that he's aware of, but if there are, then people please let us know, because yeah, I'm not seeing issues in the specification that would require us to delay a working group last call beyond what's discussed and potentially resolved today. Obviously, we can take those things back to the list, but yeah, I think we're making the progress that rapid progress and what was effectively requested of us to do to help out web transport and the mock working groups. David?
David Skenazy, web transport enthusiast and chair. I wanted to thank the working group for moving this one through this quickly. Like this has been like it hasn't been rushed, but it still has been done quicker than we've been, and that's really good because we expect it's not like this is the only issue remaining in web transport, but we expect this to kind of be the long pole. So from my read of the draft, there aren't any open issues in how the session went today. I think our only limiting thing for working with last call is implementation. So I'll take an action item to like follow Victor in the hallways to make sure that Google's implementation is ready soon as well.
He stood right behind you in my eye line and he's smiling. So great. Okay, cool. Thank you.
Thanks.
Yeah. Okay, cool. Sorry. Thanks. How do I stop? Okay, who's next? No, Robin. Okay, we have Robin. Talk about Q-Log. Robin, go ahead.
Yes, I assume I'm hearable. All right. Welcome all to another Q-Log update, and to celebrate the latest box office hit, this will be the Barbie edition. You see, can I move the slides myself?
Yeah, you just have to ask for it.
Aha, I did that. It's a slides request, right? Oh,
yeah.
There we go. So updates since last time. We had a little bit of work, especially editorial updates. We did have some breaking changes. So we up to the version number, more on that in a second. One of the biggest changes is that we now have support for all of the extension, Quick and H3 extension RFCs that we decided last time that we would include in the main documents. Additionally, we also had an early SecDir review, thanks to Legally Blonde Barbie there, and especially Dan Harkins as well. No issues were found specifically around security and privacy for now, and other recommendations were pushed through in this version as well. So breaking changes might sound big and bad, but it's actually relatively simple. It's just some renamings. So in Q-Log, every event has what we call a category. For example, you would have a transport category, and in there you would have a packet sent event. Those categories turned out to be a bit too high level once we started adding more stuff, and so we decided to rename those to more protocol specific names. So for example, HTTP became H3, and transport specifically became Quick. So this doesn't actually change any of the functionality, but it does mean it's a breaking change because all the implementations need to change how they call things. We do have a few other issues that also are breaking changes in a minute. So for those and in general, I would say people who are currently implementing using QLog, hold off in renaming all of these things until maybe next drafts or even the ones after that, until things settle down a bit more there. Then, in regards to the RFCs that we now added, so as we agreed upon last time, we would add everything up to and including the RFCs that were finalized in 2022. So, for example, we have the GreaseBit extension, we have the extended connect for WebSockets and HTTP3, and then we have the extensible prioritization for HTTP3, helped by our Battlefield triage Barbie on the right. All of these were relatively straightforward to put into QLog, very minor changes. One thing we did add explicitly for the prioritization one is to have a separate priority updated event, even though most of that can be inferred from other things that we log. It's always nice to have a separate event for these kinds of things. I think most people would agree. So these were easy. The one that was slightly less easy, or the two that were slightly less easy, were the datagram ones, so for Quick and H3. We previously proposed these as a separate extension draft, as you might recall last time. We then decided to merge all of these into the main document, so that's what happened now. Important to note again, this is only the basic datagram frames and things around that. So we do not have anything about the capsule protocol in there, just as an FYI. And as part of this change, we also made another breaking change where the data moved event is now split into two: stream data moved and datagram data moved, because now we suddenly had two types of data that could have been moved around the stack. So that's kind of what has happened. That's what in the current drafts. The next parts are things that need to happen or things that we have proposals for. Starting with this last thing, because that has further impacts, because now we suddenly have datagrams, obviously, to deal with. The question becomes, what is a datagram? Because we also have minor support in QLog for UDP level logging. We used to have this as part of the transport datagrams sent event. You do things like packet coalescing inside of UDP datagrams. That made sense, but now that transport has been renamed to Quick, we now have Quick datagram sent, but we also have a Quick datagram frame that you can log. And so it might become confusing what exactly is a datagram at what level of the stack. So the current proposal is just to rename, to have a new category basically, to do the datagrams, the actual UDP datagrams events as actual UDP category name there as well. I don't think this is very controversial at all, but it's again another breaking change that will happen in a next set of drafts. It's the main thing that would happen there. Then the next thing is that we want to have a better approach to how we version QLog and how we actually say which additional QLog documents are we using in this particular QLog instance. Last time we had the proposal on the left, where we wanted to explicitly link the different schema that we're using. There was a lot of discussion about how you actually link to the individual schema. We proposed just using RFC names or draft names. That was not well received. So the new proposal is the one on the right, where we will use universal resource names or URIs that are actually registered through IANA for individual documents as well, and that can then be used to list which exact events you're using in a specific QLog file. As long as you're just using draft, of course, you don't need to register with IANA, just like we do with transport parameters and everything there as well, which is what we're also doing in the current draft, just having these as placeholders. This is currently just a proposal. This is also very new. So any feedback on this is more than welcome today. We do have a precedent for this, which is also linked on the bottom of the slide for some RTP parameters are using the same approach there as well, which is something that was suggested to us last time. Then we have this
Robin,
thing.
sorry, can I just dive in there, just to add a bit more context? So yeah, the just on the slide, I wanted to like avoid doing the URN or other HTTP stuff, but hence the old design. But based on the feedback in Yokohama and some of the suggestions from Jonathan Lennox and looking at the RFCs of how RTP does this, it doesn't seem terrible. I mean, if people have strong opinions against that kind of thing, like please go to the issue or the PR. But I wrote this last night at like 2 a.m. So Robin made this slide because my eyes had gone cross, so I couldn't anymore. So it's very raw, but I think this can actually work. And maybe there's a few tweaks or whatnot. But this is really, the whole thing is really key to making sure that QLog as an extendable format can be extended properly for people to use. So we can actually punt on new things that come in constantly and get this work done. So it's important. The shape of it is malleable, but I personally really appreciate us getting this fixed for the next draft. Thanks. Go ahead, Robin.
I agree with all of that, Luis. All right, so for a very long time we had this well-known URL in the draft there as well that people could use to request QLogs from an endpoint. It turned out that made just about as much sense as the Barbie telephones shaped as high heel shoes on the bottom right. So we asked the list very recently, and they all decided, or all agreed it would be better to remove this from the QLog drafts. However, we do have some people that would like to see this general concept of having a way to extract logs from endpoints, and especially in a privacy and security sensitive way, to live on in some form, probably not QLog specific. We also know that there are existing how should I say, conflicting proposals on how to do that. I think Fastly or Kazuo had one of these for their current approach as well. So it might be worth keeping this around, but not within the QLog, or maybe not even within the QUIC working group. So we are looking for people who would like to take this up further there as well.
So,
I suggest we take Martin's. Yeah.
Sure. Hi, I'm Martin Duke, Google. This is a few slides ago, but there's no need to go back. On the with this datagrams, this datagram counter, are you like introducing a new UDP namespace specifically for that in the QUIC document?
Yes.
So like, this is maybe just a document like inside baseball thing, but if we were later then to decide to do a UDP QLog, I don't know, module or whatever you call it, would you then have like a separate draft for that and then have to reference this thing because you got this bit of UDP over there?
Yes, likely.
Okay.
This is similar to the splitting the queue back in the H3 draft. We also have TLS related events within the current QUIC draft and so on and so forth.
Well, if that's
yes,
the
there
norm
is some overlap, but that would be the goal. Yeah.
All right. If you've already gone down that road, then that's fine. I was going to suggest maybe like having a UDP is not that complicated. Like you could have had a little UDP module and just like do the extra work to flesh it out. Or I don't want to suggest another document, but have another document. But if you've already got this stuff scattered everywhere, then never mind. I think we're probably stuck. Thanks.
Yeah, just to respond to that quickly. I mean, if you're volunteering to write that and do it in a transport area, then we could help support you. But actually, what was nice, what I realized yesterday, looking at the URN stuff, is these URLs you can actually have single documents include multiple schema and reference them with fragments and do all kinds of stuff. So the additional schema here would be effectively a partial UDP, like 1 or 2 events here, and then to do a full UDP support, you would then link to some additional components in another doc if someone wrote that. So I think it could kind of work, even if it's clunky.
Yeah, I mean, look, I mean, I'm not going to write it. I would support it going to TSWG if someone were to write it. I guess it's a little bit of a bummer for somebody who wants to go do a TLS model or wants to implement a TLS QLog model or a UDP QLog model in the future. They have to read like 7 different RFCs. But like I said, I think we're already down that road, and I don't want to, tip over the cart that badly. Thanks.
All right. And yes, we've been down that road. I think the current approach is the better one. The main remaining thing, and I just in a flash updated the slides specifically for Ruby in the chat to include Ken, because we're once again asking for your help with multipath and connection migration. While they are definitely linked and important for Quick as a whole, they are somewhat strange to us as QLog editors because we have very little implementation experience. So they are kind of like Ken to us Barbie connoisseurs. So we kind of need some Ken experts to kind of help us out. If that will not arrive, we will just keep a very, very simple concept there, just having what we call a path ID, which is basically just a string. You can do whatever you want, which is very application specific, and that you can use then to log any kind of path and multipath information in there until someone actually makes a multipath extension down the road. We believe this path ID can support everything we currently don't have, even things like logging IP addresses for whatever paths you're trying to probe, which we currently do not support, just something to be aware of. But it would be very, very rough and very implementation specific. However, again, if we don't get any more concrete feedback, hopefully from people currently implementing multipath, doing the interrupt from multipath, I would be very interested in knowing how you are currently debugging this internally and what we might learn from that. If that doesn't arrive by next draft, we will just have the path ID and move on to other things. Finally, one of the big open items is the QPAC event reworkings. We had hoped to get something proposed for this time as well.
Robin, sorry
yes.
to cut you off. Miria's joined the queue. I'm presuming to speak about the multipath stuff.
Great.
So.
Yeah, so I guess path ID is an opaque field, so you can put whatever you want there. But like, given where the draft is right now, did you consider just putting the connection ID directly in there, or like actually both of the connection IDs eventually?
Yeah, and those are, you can possibly log those in many different ways already in Quick and QLog currently as well. Either as part of what we call a group ID or in individual packet events. So as long as it's in the Quick layer, it's fine.
Put it as a top level feed to kind of all the other logs you have basically, instead of the path ID field.
Definitely an option. I don't know enough about multipath to know if that would be enough or not.
I think that's mostly what we're doing right now, where we hacked it in.
I was hanging and lurking at the hackathon on the weekend, not strictly hacking on interop of multipath, but I was speaking to a few people and came up with some ideas of maybe how something like QViz could help visualize the comings and goings of paths. So a bit like a stream multiplexing view or a waterfall model, something like that. And I can visualize how it would work, but I don't know what the events are. So let's take that part of the discussion offline, because maybe we have a use and that can help drive the design. Christian, go ahead.
Yes, I mean, Mark, excuse me. You're asking for help on a volunteer to help you handle that, and I'm willing to start helping there. The main issue with multipath is not so much having the path ID, but enabling tools to match path-specific packet numbers, path-specific acknowledgement, and things like that. And for example, currently when you use QViz with a multipath log, it's kind of weird. And that's what we have to do, basically make sure that we have enough information in the QLog that a new version of QViz could handle multipath properly.
Yep, exactly. And I would love to work with you on that.
So yeah, I mean, I'll try. I mean, I'm very busy, so I mean, I may not be the best person. If someone else volunteers, I'll be very happy to help them too.
Yes.
We need to move on. Robin, have you got just the last couple of slides? Can you whiz through them?
Yep. So, as any proper movie, we end on a cliffhanger for part 2 next summer. So the QPAC stuff is coming. We just didn't get it ready, and that was basically it. This is the end, hopefully not of all things, this is just a summary of what we talked about. If anyone has any more comments right now or otherwise on the list or on the GitHub issues, of course. Thank you all.
Great. Thank you, Robin. Thanks for being in a weird hour for me. I don't even know what it is. Late, I guess. Okay. Up next, we've got Ian. There was more slides from there. We're just going to share the slides we have. They might not be precisely what we want.
Yes, please. After what? Yes. Well, there's not much difference. I only have 10 minutes though, so 2 of the slides we're going to skip over because I don't think they're actually critical to cover. Okay, so here's an update on ACK frequency. I'm Ian Sweat. Co-authors are Miria and Jana. So thank you for both their help. We skipped this slide, but it's here for reference. So the changes since 04, they're mostly quite small. Even the normative changes are quite small. So we removed a must that really just didn't need to be there. Removed a should upon migration because it was a kind of an unnecessary recommendation. So things like that. There was a new error code added, speaking of error codes, for an invalid regressed max act delay value. So you can tell that from other error codes. So if people are error code nerds, then they should check out that issue. But these are pretty small changes. There are some other editorial changes, of course, but those are even smaller. Next slide. All right, let's go through some open issues. So this is the big one. So I would like to get this settled. Martin, I believe, opened this issue. Is that okay? I think Martin suggested that though immediate ACK is worthy of having a 1-byte frame type, which we kind of spent some time on in the past, ACK frequency was going to be sent much less often. And given the number of 1-byte frame types we have, maybe 2 bytes is just totally fine. I don't have a particularly strong opinion on this. But I would, and I think it's completely true that ACK frequency is going to be sent a lot less often, right? I mean, at the most, I would expect it to be sent, every maybe 10 RTTs or something like that. And even that seems unlikely. It's or once in the connection. Do people have a strong opinion on this? Besides, I believe, Martin, do you still have a strong opinion supporting this? Can I ask you a question?
Yeah, like you said, I think it's very likely that this is going to be sent 1, 2, 3 times per connection, and that's it. And so it seems like using our prime real estate for this is just a bit of a waste, really.
Sure. Christian.
Maybe I'm doing it wrong, but I'm sending, I see logs in which the ACK frequency is sent much more than once per RTT per connection. The ACK frequency has a delay component, which depends on the evaluation of the RTT. And the RTT will change, quite often. So it also, the ACK frequency also has a component that depends on the evaluation of the congestion window, because that's how you compute how many packets you want to have. And so those things, first, they change rapidly during the beginning of the connection. And then, yes, they change slowly, but they do change. And let's not forget that most connections don't go much further than the startup. So, yeah, I could do with 2. I don't care that much, but it will be sent more often than you believe, especially if you look only at the short connections.
I think all of Christian's points are true. I think the question is, does a byte matter? On the other hand, we still have, 60 more code points to give out or something. So okay. I'm going to change it to 2 bytes unless someone strongly objects. Is that okay?
Kazuho, this is not a strong opinion, but I kind of prefer using 1 byte because when you're at a tail, it's just easier to have the space for filling in the byte rather than having to check that there are 2 bytes. Not a strong opinion.
Okay. Yeah, ACK frequency is already a variable length frame due to the nature of it. Like it's not a 1 byte frame like immediate ACK is. So I guess that would be another argument why maybe the extra byte matters less because you're already throwing some varants in there. Is that a convincing argument to people? Okay.
I would say just
Move it.
just
Okay.
change it, and we'll see if anyone really wants to fight it.
Okay. Thanks. I just don't want to, I mean, we're getting pretty close to the end, so I'd prefer not to revisit this. If Martin has a suggested code point that's 2 bytes that he would like to suggest, he can feel free to do that. Skip this on the issue. Great. There's a question or an issue opened by Gory about sending an immediate ACK soon after an app limited period. I think the specific concern is if for some reason we created settings where we only sent 1 ACK per RTT, which is of course a very low number of ACKs per RTT, and you come out of full quiescence, you could actually go 2 entire RTTs without receiving a single ACK while sending, which seems like a very long time without any sort of acknowledgement feedback. I think that's a valid concern. And so, you know, the question is, do we want to add some sort of text around when coming out of quiescence, you know, including like an immediate ACK frame or something in one of the earlier packets coming out of quiescence to make sure that there's some fairly timely feedback. Or alternately, coming out of quiescence, we could also say, you know, maybe you should send an ACK frequency frame and like drop down the ACK frequency so it's a little bit more frequent than it was before. Or like, I mean, there's a number of kind of technical solutions to this issue, but I think it's worth probably adding some sort of text would be my inclination, but I'm feeling like maybe we could just make an editorial comment. But if people, I'm really looking for feedback on, do people want an actual normative statement like it is recommended you do blah, or are they happy with just here is like an issue that could happen, you may want to be aware of it and adjust your you know, respond accordingly. Miria is technically first in the queue. Okay.
Mira said I could have priority. Gory Fairhurst. So I don't like do nothing. This could be much, much worse when you get the RTT wrong because the RTT was varying a lot because you wait for 1 RTT that you previously thought was the right RTT and now the RTT is much shorter. So this can actually reduce the amount of feedback you've got quite a lot. So I would like to see recommend generating an ACK somehow. And I really don't think we should be prescriptive about what way you do that. So I don't know how you find that text, but that's what I would like to see.
I'm happy to write text around like ways that one could like accomplish this. So I think this is, again, it's very much for me around like, is this normative or not? That's the feedback I want from the working group. So I understand your opinion though.
And I think if we want to go for another BCP, the BCP on RTT estimation said you should do it once per RTT of the current RTT, expecting that you send every other ACK in TCP, I know. But so it kind of feels close to what we should really be doing to be a sensible citizen on a varying internet.
Okay. If there's I think I mentioned on the issue, but if there's a specific informational reference, like a section we should reference that like kind of really like informs this, you pointed to an RFC, but it was fairly long, then that also I think would maybe err me towards like something normative. But Miriam.
Yes, I want to disagree slightly, but I think we're still agreeing in the end. So I think the issue you're talking about is not specific to this draft. This is a general issue, right? If you want to like talk about it, then like you can talk about it in any draft about it. However, the connection to this draft is that we have the immediate ACK mechanism here, and that can be helpful in this situation. So I think it's good to like mention the situation and recommend that the immediate ACK could be used, but I don't think we need a normative reference or recommendation because it's not an interrupt issue, just like editorial text is fine.
Yeah. No, I didn't want a normative reference. I didn't know if there's an informational, but yeah.
Sorry, I didn't mean reference. I don't think we need to use normative language.
Okay, thank you. That's what I was looking for. Okay.
Christine?
Yeah, pretty much what Miria said. I mean, you definitely don't want to have a list of normative statements saying this is when you send the immediate ACK, because I mean it can be for a ton of reasons, and it's really something that will vary from implementation to implementation. You may send one after a PTO. You may send one when you are doing a congestion bandwidth estimate. You can send one in many cases. So I would hate to have a list of normative statements saying do this, do this, do this, because it will be interpreted by someone as a protocol error if you do it that outside of the list of prescribed recommendation. And so there's a pitfall there. So please don't put any kind of normative language. And yes, and be very careful when you edit it to say, well, you may do this or you may do that and blah, 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 but it's that it doesn't look normative in any way.
Okay, Martin.
Martin Duke, Google. Definitely do something. Regarding editorial versus recommended, I guess my question would be like, how sure are you about this? I mean, certainly my intuition is that this is a good thing to do, but the only thing I really know about gesture control is that often intuition is wrong. So like if we have data or model this, formally or something, like, yeah, this is definitely what people want to do, we should recommend it. If not, I don't think we want to have recommendations that turn out to be bad when we actually deploy it.
I don't think we have data that's solid enough to say that this is definitely the quote. There's no right answer here. I think this is a consideration one should take into account, but I do not think anyone can substantiate data. Martin.
Yeah, I think we have the wrong end of the stick. If there's any recommendation to be had, it's on the receiver. You don't have to send a frame in order to get the behavior that we want. If the receiver receives a packet and they haven't received a packet for what they think is more than an RTT, maybe they should just send an ACK. And then we don't have to worry about what it is that we say about immediate ACK. Now that's probably something that RFC 9002 should have said.
Also useful for a PTO, by the way. I'm just throwing that out there.
All of the above, right? But this document can say it, but I think we should be somewhat careful about sort of detaching from the immediate ACK semantics here and be very clear that this is a gap, a mistake that we made perhaps in 9002 rather than something that's attached to the frame that we're defining.
Technically, acknowledgements are 9,000 still. But sorry.
Oh God, yes. Well, okay. So it's my RFC.
No. You should blame me anyway. Anyway, but I agree with you. Yes. I will. This draft just exacerbates an existing issue, basically.
Right, and I think that's worth highlighting.
Okay. Right.
No. Mike, please.
Miria asked whether or not we should have some sort of normative text, or non-normative or whatever. I have no opinion on the distinction between the latter 2 points on this one. We should have text, yes. But I'm saying the shape of the text is about the receiver behavior, not the sender behavior.
Gary's going to respond.
So Gary first, quickly rebounding on that. I think we actually got it wrong because we didn't think about the dilution of the acts that would happen afterwards when we publish this. So I think probably we should describe it well. And I think Martin was right. It should have been a receiver behavior rather than something the sender says, because the receiver knows. So let's try and write that paragraph, because that might actually have non-normative text on this document.
Okay, happy to do that, or other people can contribute text as well. Okay, I'm out of time. Do I get an extra time for like one more slide, or Mark?
Yes, you do.
Okay, thank you very much. Nope, skip the slide. Deployment experience, yay! Okay, so Matt has been kind enough to contribute some production experience. Here you see some interesting information. I'm going to skip this slide, but I want to move to the next one because I filed 2 issues and I want feedback. So 2 takeaways, and really Matt should be presenting this, is one, you really need to PTO with immediate ACK well, or you could do the thing we just discussed in immediate ACK after an RTT of questions if you mess with the reordering tolerance. And that's critical to performance. So I filed an issue for that. And you need to be really careful with min-RTT here because min-RTT can be enormously smaller than smooth RTT. And you can end up with cases where, say, like the min-RTT is 10 milliseconds, smooth RTT is like 100 milliseconds, and you end up, getting a ACK every 2.5 milliseconds, on a connection that really does not need an ACK every 2.5 milliseconds. Intuitively, that seems obvious to me because I've mess with congestion control a lot, but I don't think that's obvious to a typical reader, and I think it's probably worth adding some text. So here we go back this question of like, these seem like just performance considerations that I can add editorial text on, and maybe it overlaps with some of the previous discussion. But if people think I need normative text about either of these issues, please, you don't have to speak up now, but like, please at least comment on the issue and say so, because otherwise I'll probably err towards non-normative text. Did you want to add anything else, Matt, given this is your data?
No, not really. But also, as a follow-up to our nice bike shed earlier about the size of this, in practice, I don't think it really matters whether we do 1 or 2 bytes also in deploying it. So just take that as you will.
Sure. Thank you, everyone. No, really.
Cool. Thanks. And I think, you know, what we're seeing is, you know, the draining of the open issues on this document. There's a bit of follow-up work to do, but that's, you know, we're probably getting in a position of working group last call and readiness. But again, implementations and interop would be good. So if there are other folks who are experimenting and can comment on the list, whether they have data or just interop success, that would be useful information to help us decide whether to run the process and accelerate it. So thank you, Martin.
Hi, me. Remember this draft? Oh, we've been silent. We've been quietly beavering away. It's taken a really long time to deploy. This turns out Google's big. Next slide. No doubt you're all constantly thinking about the minor details of this, but in case some of you have not been. In the very first, so of course, QUIC-OB is about a structured connection ID that does a couple things, but mainly it's about encoding routing information for the benefit of load balancers. And then in the very first byte of the structured connection ID, there's 2 bits for config rotation, which is of course 4 code points. One of those code points is reserved for the server saying, I don't have any config, so this connection ID does not contain any routing information, so do something else. And so that leaves, of course, 3 configs, which generally would just be different keys, assuming you're doing encryption. And so what the outcome of that is, a sensible way to deploy this would be have your load balancer have 3 sets of keys, essentially like the next one and the previous one. And then when you try to roll new rotate keys or roll a new config of any kind, essentially if you have these 3 code points, you kind of work out the logic. You can update things in any order and everything will still work during that update process. And real condition is that all the load balancers and all the servers have the config before you try to roll a new one. That is kind of the condition. Next slide. Okay, so the proposal TLDR is to do this. So the other thing I mentioned here, so the rest of this first byte has an additional purpose, and that is, although this is separate from the theme of load balancers, it is like a schema for like a structured connection ID. And the other thing that is out there is that the hardware people that want to do crypto receive offload need some way to have a self-encoding length in the connection ID. So if you're doing that, you can use that field. Otherwise, that's just random stuff. Next slide. So why do we want to do that? Well, the point of holding this draft was to get some deployment experience and talking to people who actually operate Google's network, which obviously is pretty big, say that they really can't guarantee that condition, that everyone will get the config before we roll a new one. And so, so they're asking for a 3rd bit that has some modest benefits and has some modest downsides. Next slide. Okay, so what are the downsides? And they're not big. One is that, of course, the connection ID cannot be any longer than 32 bytes and be self-encoded there. Now, of course, QUIC v1 and v2 limit it to 20 bytes anyway. I don't anticipate that getting a much bigger unless we end up in a post-quantum world with like gigantic connection IDs. And if we end up in that situation, then like there'll be a lot of silicon out there, and these hardware encryptors would have to be replaced, and that would be sort of sad, but certainly not an immediate problem. And then the other thing is that it's kind of an attractive nuisance. Next slide. so just here's a situation: you have a CDN, and you've got multiple customers on the same IP address because you are trying to help user privacy. So you're running ECH or something and doing SNI switching. Next slide. But you're also doing QUIC-LB, and well, how do you get all these? How do you like decide what backend to go to? And one answer is to give everyone the same keys, which obviously has some trust problems. Next slide. Another option is to just try to use all these config ID code points to like give everyone a different config ID. But if you think about this for a little bit, you realize this completely defeats the purpose of ECH, because then every packet identifies what customer it is going to, and that is pretty easy for an attacker to determine. So like there's, I believe, already language and security considerations about this, like don't do that. But you know, people don't always read security considerations, so we are kind of giving people a foot gun if they're not like thinking stuff through carefully. So this is not a huge problem. They are minor problems, but I do want to call this out. Next slide. Okay, so so you know, I know the set of people that care about this is not that large, but I do want to get some. I didn't mention in the other slide the effect of having this misconfiguration where the load balancer of the server out of sync is that you will get that the server will end up generating unroutable connection IDs that are not known to be unroutable. They'll be misrouted, and that essentially what that means is you will have the first flight go somewhere, and then the second client flight will go somewhere else, which can result in stateless resets, which might not work because you're in the middle of a handshake. Ian and I made a pass at figuring out what this would mean for Chrome, and I think we decided that under many circumstances you would end up with a significant increase in latency, maybe a handshake timeout. I can't speak to other clients and how they handle like TCP fallback and so on. So so like the severity of this problem is also not that large. So I would be interested in like hearing from anyone who thinks that those drawbacks are a much bigger problem than I do. Anyone with a client where like this like I don't want to say black hole, but this one flight successful, second flight not successful problem is like going to really ruin your performance. And then thirdly, anyone else with a big deployment says, no, your guys are really missing the obvious thing here. We have a much better fix for this, and why are you having trouble syncing your stuff? And I'll open the floor to comments at this point, if there are. No one's in the queue. Okay, well, I guess that's ours. No response.
Kazuo?
Kazuo, hi.
Just do it.
Okay.
It's safe.
All right, sounds great. Then we will go a couple more rounds with our ops guys to make sure that we really need this, but I'm fairly confident that's the case, so I would expect to land this PR in the next month or so. Thank you.
Thank you. Up next is QUIC. Yes. Lovely.
Hello, everyone. Yunfei from Alibaba. And this presentation is about quick enable service differentiation for traffic engineering. And I'm here speaking on behalf of my collaborators, Zhilong, Yanmei, and Miriam. Next slide, please. So the first question, what is the problem we're going to solve here? Here we have a backbone network, and between two edge routers, there are two passes indicated by different color. And the blue one is called the premium pass, and the premium pass is tailored for low latency traffic, more interactive traffic. But the downside is it could be more expensive, and the bandwidth resource may be limited. And the green one is called a regular pass, and the regular pass is tailored for bulk traffic transfer. It is extremely low cost, and the bandwidth capacity is very large. So the goal here is to balance the cost and the performance. What I mean by that is we really want, within a quick connection, the critical data to go through the premium pass to ensure good performance, while the rest of the data to go through the regular pass to reduce cost and save money. Next slide, please. And so to do that, we need service differentiation. So within a quick connection, there are basically two types of differentiated service for, and the first one is for prioritized streams. So basically here you have two streams. Stream 0 is a high priority stream, which carries interactive traffic or command or signaling, so that you want the stream 0 to go through the premium pass. Well, stream 1 is not that latency sensitive, so it's better for it to go through the regular pass to reduce cost. Next slide, please. And the second type is differentiated service for prioritized packets. For example, for loss recovery packets, because you already have a loss, so that means you have latency. You really want the loss recovery packet to go through the faster pass as much as possible. And also another type is the handshake packet, because we want to reduce the handshake latency. So we really want those two specialized packets to go through the prioritized premium pass, while the rest of the packet, because maybe they're not that latency sensitive, so it's better for them to go through the regular pass to reduce cost. Next slide, please. And how can we implement this? To implement this, we really need our backbone network to understand the priority information, but QUIC is end-to-end encrypted. So it seems that the only option for us to do this is to embed priority information in pass ID. So the proposal here is to leverage multipass QUIC plus embedding priority information in pass connection ID, because right now in multipass QUIC, we have different paths have a different CID. So it naturally provides the opportunity for us to embedding this information. And in the action, you have a client and you have a server running multipass QUIC. And the CID 0 here is for the high priority traffic, and CID 1 is for low priority traffic. So in order for the server to send traffic on high priority path, it basically uses a scheduler to schedule the packet on the high priority path. And at the edge router will try to parse the CID and decode the information. Now it looks at, okay, it's a CID 0, so it understands the semantics. It can then apply traffic engineering policy to the packet. And in doing that, it can simply apply SRv6 seed or MPL as a label to direct traffic to the desired path. And what is different of this proposal from the current multipass QUIC is that the typical multipass QUIC application scenario, we usually have multiple last mile connectivity links, for example, cellular and Wi-Fi. But here we could only have just the one last mile connectivity. So for example, you only have one LTE link, but you will have multiple passes in your backbone network. Next slide, please. There are a number of benefits of this proposal, we think. The first one is it allows you to achieve a stream level and packet level service differentiation at a very fine granularity, whereas traditional DSCP, you can only control your queues at a 4 tuple or connection level. And the second thing is that your user space application has a direct control. And in this way, your backbone network service differentiation capability is directly exposed to the application, and the application can assign priority to packets using a multipass scheduler. So it is quite flexible for the application to use this feature. And the third thing is that the packet reordering, RTT estimation, and pass congestion control are all automatically handled by multipass QUIC framework. So really, we don't need to do any extra work here. And the last but not the least, right now the priority information is embedded in the connection ID. So it's a queues marker, and which will not be easily interfered by middle boxes. Whereas for DSCP, it's quite often is that the middle box can change the DSCP value or remove the DSCP value. But for this proposal, we don't have this concern. Next slide, please. Yeah, and this is the last slide. So we're thinking about why it should be standardized. The first thing is that we need to think about how to the algorithm and encoding rules for the CID. The first thing is that because due to the privacy concern, we really need to some obfuscation, because we don't want a third-party network or a public network to understand your priority semantics. The second thing is because QUIC-LB also use a server ID encoding in the connection ID, so we need to think about the coexist with server ID encoding here. And the second big reason is that to use this feature, your client and server need to negotiate. For example, the client needs to understand, does our infrastructure support this feature? And if so, how many priority levels in total that the infrastructure supports? And further, also the application also need to know how many priority levels the application want to use. And after the negotiation, we need to take care of the CID issued by the new connection ID frames, because each CID then issued by the new connection ID frames must consider CID encoding rules and the number of priority levels negotiated. And I think that's all. We really, if anyone find this an interesting use case, or if you have any feedbacks, please let us know. Thank you.
Thanks for the presentation. We have a lot of people in the queue. We have a little bit of time in the agenda until the end of the session. I would ask people to be brief and concise. We had a slight IT issue, so Watson's first in the queue. Come on up. We're going to put Ted in second so that he doesn't lose his place, and then we'll just run the queue through. If you want to actually physically queue, that might help a lot, like the old days. But Watson, go on.
Watson Lad, Akamai, person after me, wait a moment so I can get back to take down the notes. So with this proposal, it seems that the diagram you drew shows one network between the client and the server. On the internet, that's not how it works. You have multiple different networks, and it's very unlikely that the path that's being traversed is known, or that it's you even have the relationships that allow the DSC to be exposed here. The other thing is, by having to sit encoding, the obfuscation for privacy, if you're differentiating by stream, you're now exposing a lot more about what kind of traffic's flowing over the connection. That needs to be carefully analyzed.
Oh, okay, yeah. So for our application, because we, like a cloud provider, we also have this global backbone network. So usually it's like to the traffic to the edge pop and through our backbone network and to our data center. Yeah, but I understand. So in other cases, you have so many ASs, right? And the traffic will traverse. So that's a different application scenario.
Cool.
QUIC defines.
Sorry. Ted is next. Ted. No? Come on, Ted. You can do it.
Ted Hardy. I actually dropped to the bottom because of a misclick, but thank you for taking me in my original place. So there's about 18 different things wrong with this, and I really encourage you to go back to the drawing board and start over. One thing I would encourage you to start with is explaining why you want to do all of this in a single QUIC connection as opposed to using multiple QUIC connections with different DHCP markings. It's really not clear at all how you would use this outside of a single SRv6 domain. This is terrible for leaking information and potential privacy concerns. And frankly speaking, if you can't trust the DSCP markings from a single client, why would you trust this? And lastly, the way you would have to coordinate this between servers and the orchestration system so that you would be able to do this kind of modulo system is just going to be a gigantic operational pain, and you won't want to do it. Thank you.
Thanks, Ted. Martin.
I had a lot to add to this list, but I think Ted had made a good point.
Yep, Alex.
Hi, Alex Trahowski, Google. I wanted to point out two problems. One is that you really want to do your prioritization at quick frames, not quick packets. So this is not going to work very well if you're doing a prioritization at packets. Second of all, if you control the entire network, why don't you just use like GRE plus MPLS NCAP or something if you can't use DSCP bits? Also, why is your server so far in your network? Please move your server closer to the user and like do multiple quick connections to your core backend or something like that. I agree with everything Ted said.
David?
Hi, David Skenazy, architecture enthusiast. +1 to what's been said before, and then I'll add, this sounds a lot like the application-aware networking work that was proposed and that is still ongoing on the list. So I encourage you to go there. I think they're trying to refine their problem statement, and I still don't see this recurring need to push this information onto the network. It still seems like there are too many privacy problems, but I would say maybe go there, get started on, understanding that, And then we can talk about encodings. I agree with others that Quick is probably not the best place, but let's first see if we can reach agreement on whether this concept is a good idea before we look into encodings. Gary?
Gary Fairhurst. Everything Ted said sounded good to me, but I'm a transport enthusiast. I also see concurrent multipath and the way in which you use concurrent multipath to do retransmissions and maybe congestion control, so it bundles an even greater set of things in here. I think there's too many things in one draft.
Thanks.
Martin Duke, connection ID enthusiast. A clarifying question and a comment. So clarifying question, is your intent to have like commonly known code points for this, like DSCP, or is this on like a per network completely custom mapping?
Yeah, it's more like I think custom mapping. It's different than DSCP because DSCP is per connection, but here is like you have multiple streams,
right?
And you really want different stream to go with different paths.
Yeah, I got that. But I just wanted to know if there's a registry. The answer is no. Okay. So the other thing I will say is like modulo, whether or not this is a good idea, and I think people have had a lot of feedback on that. QuickOB is probably a flexible enough framework to fit this in. I mean, obviously, at some level, a load balancer is essentially a router, and the architecture of these structured connections does allow for multiple tiers of routing / load balancing. So you could absolutely, if you like configured it right, you could absolutely use the QuickOB framework to support something like this. So if we decide to move forward on it, I think there's a discussion on how the documents work. Maybe this is an informational thing on how to like tune QuickOB to do this thing or whatever, but we can get there. All right, thanks. All right.
So Richard Schaffenegger, unfortunately, everybody in front of the in the line has already stolen my thunder. It is quite frankly not really clear to me what the problem statement here is and how you want to negotiate this with the infrastructure as you have here in the slide. So again, all the other points that have been raised before me, I fully support. So I don't think that this is not ready. Thank you.
Okay. Same thing, there's a lot of statefulness in the structure. One question I wanted to ask is, for every application, their own stream is most important. Like there could be a web page with 100 WebRTC connections and they'd say, oh, our stream is the most important one. When there are so many things with the same priority, how do you handle the multi-priority level prioritization? I mean,
oh, so basically your application understand the priority for
application will say everything has highest priority then.
Yeah, then you go through the high premium path, but then you actually increase your cost, right? Because the bandwidth resource there is scarce.
But
So
as a backend service provider, you don't have control what the application demands, correct?
So here the idea is like that. For example, if you have a server, right? So for us, like this, our server side and the infrastructure side were together. So we actually have some knowledge about which stream we should prioritize. And if you get that information, yeah, sure, you can leverage this information to improve your performance. But if you don't, you just go back to your default, fall back to your default settings.
Okay, so like a rule-based priority engine,
Yeah,
which is with the service provider.
Yeah.
Okay, I don't. Okay.
Spencer Dawkins, Ted Hardy enthusiast. And also learning from the past enthusiast. The Path-Aware Networking Research Group did a RFC 9049 that talks about obstacles to deployment. And I think if you do take Ted's advice about rethinking this at a fairly fundamental level, there are several obstacles that are listed in that RFC that I think apply here. And it's not that they're, for most of them, it's not that they're fatal, but it's that you need to be aware of them and you need to think about, if we're going to do this anyway, how will I overcome this obstacle because the obstacle is real? So I was the editor for that RFC, and I'd be happy to talk to anybody about applying that to anything, but especially to you.
Okay, thank you.
And finally, Christian.
I am a Ted Hardy enthusiast too. I mean, The basic view of the application is that the network is a swamp that is full of alligators and middle boxes. And you definitely don't want to tell the alligators and the middle boxes which of your information is important, because you're pretty sure they're going to mess it up. Now, if you are going to do multipass, there is a much simpler way to do what you describe. And it's basically assume that you have one pass through an expensive network, and you can define that pass with a particular for tuple. Then the only thing you have to do is add a pass status to that pass that says it's for priority stuff only. And then once you have set up the status to priority, it's up to the endpoints to decide which of the application data goes on that priority pass or not.
Okay, so we're slightly over time, but I think the discussion now has been useful to hear. You know,
Thanks for the feedbacks.
Yeah, I think you can have a lot of discussions with some of the people and see maybe if take on board the feedback. Martin?
Yeah, Martin, we might have to keep this to kind of an FYI without a cue since we have so little time, but Martin is going to talk about another nice topic, which is NAT traversal.
Yeah, I expected to have 20 minutes for this, so
Yes.
I'll try to be quick. Can I have slides, please?
Lucas is clicking buttons, so we'll see. Yeah, start talking.
Okay, I'll make it very quick. Version 1 defines that in Quick version 1, the server is always publicly reachable. The client might be behind a NAT, so we need to consider things like NAT rebindings. V1 also defines how a client can migrate from one path to another, like from a cellular interface to a Wi-Fi and back. Next slide, please. So that's quick. ICE, there's another RFC called ICE 8445, which can be used to get through NATs if you have two nodes that are behind NATs. Next slide, please. The way that works is so you have two. ICE calls it agents, basically a client and a server. Both of them gather candidates, meaning they discover what addresses they might be reachable at. Then they use a signaling server to exchange those candidates. They run a matching algorithm to form pairs of candidates that might be a path a direct path to communicate. Then ICE runs connectivity checks. It's basically sending and retransmitting packets on those candidate pairs that go through the NATs, punch a hole through the NATs, and allow the packet from the other side to make it through. You will end up, if you're lucky, with one or multiple paths. So you need some logic to nominate the path that you'll actually be using. And then you do some keep alive. So this is all handled by ICE. The purpose of this draft, next slide please, is to make it possible to use Quick in a peer-to-peer setting. There's a lot of use cases for this. Like one of it would be as a building block for WebRTC over Quick, which will be discussed in other working groups. And there's a lot of other peer-to-peer protocols that this would be interesting for. Next slide, please. So my document defines 3 different modes, and I won't have the time to go through all of them, but the first one is there basically just for completeness. It's very simple. You run the ICE algorithm that I just told you about to completion. ICE then tells you here is a 4-tuple that might work as a path. Then you run a quick handshake on that path, and you end up with a direct connection between 2 peers. I'll skip the second mode and jump to the third mode. Thanks. So when you look at the list of what ICE does, you will see that there's a lot of stuff in there that could potentially be handled by Quick. First of all, the exchange of candidates between peers. This could be done in a Quick frame on a Quick connection. Quick already defines how to probe path that could replace connectivity checks. Any Quick stack that handles connection migration will have some logic of selecting one path out of the multiple paths that are available. So that one is handled by Quick as well. And then Quick does keep alives. So the idea is like, why don't we just use Quick to do all of these things? Next slide. So in specific, we can use, next slide. We could use a proxy Quick connection. We could, for example, use connect UDP for that, but we don't have to. So we start with a proxy Quick connection. We then do use the algorithm described for Quick connection migration to probe the path. We need a slight change to RFC 9000 here, because the server now also needs to send a probe packet to create the NAT binding that allows the probe packet from the client to make it through. And then we can use connection migration to move to that path. This has the advantage that the application can start the application protocol right away on the proxy connection, and doesn't have to wait for the whole ICE procedure to complete before being able to exchange application data. And then once we have punched the hole, we can migrate to a better direct connection and continue the application protocol. Next slide. One thing that came up on the list and on the issues on GitHub is, does this require Quick multipath? And the answer is probably not. It's beneficial to use it, but we don't need it as a dependency, because in both Quick and multipath, it's the client that probes the path. The server does not. The server only responds. Where Quick v1 and multipath differ is that you can send data on multiple paths if you're using multipath, but this is the NAT doesn't care about it, because it's all encrypted UDP packets anyway. Next slide. So I'd like to see if there's interest for this work in this working group. Obviously, this is a 00 version, so there's a lot of work to do, especially around the ICE parts.
Thank you, Martin. And also, it came up in the chat that there's related work being presented in AVT Core by Peter Thatcher that it sounds like basically mode 1 that Martin briefly described here. So I think anyone interested in this work, it'd be good to follow up with Martin and maybe also attend AVT Core. And that concludes the Quick Working Group meeting. We are over time. Thank you, everyone. Thank you especially to our note taker, Watson. And I hope you all have a great rest of your day.